Welcome, dear students, in the second video of Refraction of Light. In this video, I am going to explain about principle of reversibility of light and refraction through a glass slab. So let us start first. Principle of reversibility of light. According to this principle, light follows the same path if the direction of the travel of light is reversed. Let us see how. Let AB is a interface or a surface which separates two medium. Let this side air, or let us say medium 1, and this side let us consider water, the another optical medium, and let it be medium 2. If a ray of light traveling from medium 1 to medium 2, let us see, suppose AB or PQ is an incident ray which hits the interface at Q. Let us draw a normal at point Q. As the light is going from air to water, means rarer medium to denser medium, so it will bend towards its normal. So it will bend like this. As this is the refraction of light, if we will place a plane mirror perpendicular to this ray, refracted ray, suppose QR is a refracted ray, and if we will place a plane mirror perpendicular to QR at 90 degree, then this ray will again reflected back by the mirror, and it will follow the same path and goes to medium 1 again. So this shows the reversibility of light. Let us derive a relationship between the refractive indices of these two mediums. Now, if we will see, this angle is considered as I, angle of incidence, and this angle will be angle of refraction. For the ray of light traveling from air to water, if we will write, according to Snell's law, for the ray travels from medium 1 to medium 2, optical medium 1 to optical medium 2. According to Snell's law, we can write mu 2 1, refractive index of medium 2 with respect to medium 1 is equals to sin I by sin R. Let it be as equation 1. Now, the reflected ray which travels from medium 2 to medium 1, for that we can write, for the ray of light, for the ray travels from medium 2 to medium 1, that means reflected medium 1. We will write again using Snell's law. What we can write? Mu 1 2. Now this time medium 2 will be this 1, air. Medium 1, refractive index of medium 2 with respect to 1 is equals to sin R by sin I. Opposite we will write, because light is traveling from R to Q and Q to P. For that we are using Snell's law. Now if we will multiply from 1 and 2, if we will write mu 21 into mu 12 is equals to, then mu 21 from equation 1 we can write sin I by sin r into mu 12 is this one, so we can write sin r by sin I. So this will get cancelled and we will get mu 21 into mu 12 is equals to 1. So this is one relation. We can write it as also mu 12 is equals to 1 by mu 21. So this is the relationship between the refractive indexes of the two mediums. Now this is all about principle of reversibility. Now we will see the next topic, that is refraction through a glass slab. So let us start the next topic, refraction through a glass slab. Let A, B, C, D is a glass slab or a rectangular glass block, and a ray of light PQ incident on it. Let PQ is a ray of light which incident on the interface AB. Now if there will be no any glass slab, then this ray will travel a straight path. As we know that the property of light always travels in a straight line, rectilinear propagation of light. So if no glass slab will be placed, then it will travel like this, in this way. But as we know, this side air and this side is glass. So light is traveling from air to glass, means rarer medium to denser medium. So it will deviate from its original path. For that, we will draw a normal at point Q. So at point Q we will take a normal. Let this is the normal. Suppose the angle of incidence is I is the angle of incidence. As we know that the light is traveling from rarer to denser medium, so it will bend towards the normal. So it will not travel along this straight line, it will bend in this direction. Suppose the QR is the refracted ray. This is the refracted ray. Now again the light is traveling from glass to air. So again it will deviate from its original path. Therefore we will draw one more normal at this point R. Now we will find that the light again traveling from denser medium to rarer medium, so it will bend away from the normal and it will travel like this. We will find that the incident ray and this ray, that is RS is known as emergent ray. PQ is incident ray, QR is refracted ray, and RS is called the emergent ray. Now we will find the direction of incident ray and this emergent ray will be parallel, and the perpendicular distance between the direction of incident ray and the emergent ray is known as the lateral shift or lateral displacement, D. So this is called lateral shift or lateral displacement. This is how a ray of light get refracted through a glass slab. If we will note, then this angle can be considered as angle of refraction, as this is a normal and this is also a normal. So these two are parallels and this is one transverse line, so we can consider this angle as alternative angle. It will be also R, and this angle is known as the angle of emergence. So I, angle of incidence, R, angle of refraction, and E is the angle of emergent, and D is called the lateral shift or lateral displacement. Now we will see certain factors on which this lateral displacement depends. Lateral displacement D depends on three factors. The first one, it depends upon the thickness of the glass slab. Let the thickness be T. So more the thickness, more will be the lateral displacement. So first it depends upon the thickness of the glass slab. Thickness will be more, displacement, lateral shift will be, or lateral displacement will be more. Second, it depends upon angle of incidence. If more more the angle of incidence, more will be the lateral shift. And one more factor, that is the refractive index of the glass slab or the medium. More the refractive index, more will be the lateral displacement. One more formula we can use for this lateral displacement, and that is D is equals to T sine I minus R by cos R. This is one of the expression to find the lateral displacement. How we will get this formula? Let us derive this relation. For that, we can just draw a perpendicular this. Suppose M. This is the 90 degree. So RM is the perpendicular distance or lateral shift. Now we can see in triangle QRM, this angle will become I minus R, as this vertically opposite angle total will be I, this is R, so I minus R. In triangle, right triangle QRM, if we will write, we have to find this, so we can take sine I minus R is equals to sine perpendicular by hypotenuse, so we can write perpendicular as D, that is this one, and hypotenuse is this QR, so we can write QR, or we can write small d is equals to QR into sine I minus R. Let it be as equation number 1. Now let us first join this one and write it as N. Now this is also a right triangle QNR. So in triangle QNR, if we will take this as a cos R in this triangle, cos R is equals to, so this is cos R 90 degree, cos R that means base by hypotenuse, so base we can write as QN and hypotenuse is again QR, or we can write it as QR is equals to QN by cos R. As we know, QN is the thickness, so we can write it as T, thickness of the glass slab or rectangular glass block, by cos R. Write it as equation number 2. Putting the value of QR in equation 1, we will get from equation 1 and 2, we will write it as lateral shift small d is equals to QR value T by cos R, and this one is already sin I minus R. So this is one formula for lateral displacement or lateral shift. Now this is all about refraction of light through a glass slab. Thank you students. Thank you for watching.